Hi there, Mr. Sutton here, bringing you the Algebra 2 3-1 Part 1 homework solutions on solving quadratic equations by graphing and by square rooting. For this problem, we're supposed to solve this quadratic equation by graphing, so we're going to go to Desmos in a minute. Before I do that, though, let me just get everything on one side so this is easier to graph. So I'm just going to add 8 to the right side here, giving me negative x squared plus 4. And now I'm just going to go ahead and graph negative x squared plus 4 on Desmos. So here is Desmos. We had negative x squared plus 4. And I see here that at negative 2 and positive 2, that's where we are crossing the x-axis. So here's the graph of what I just did. So negative 2 and positive 2 are going to be our answers for this one. To solve this equation by graphing, it would be a good idea to move everything over to one side first. So I'm just going to move everything over to the left side. So I'm going to have 3x squared and then minus 6x and plus 3, all of that equaling 0. And now I just have to graph the left side of this equation on Desmos and see where it hits the x-axis. So go into Desmos. We've got 3x squared minus 6x plus 3. And I'll just move that up a little so I can see it better. So it looks like we've got just this one spot where we're touching the x-axis at positive 1. So here's the graph we just saw there. So then x equals 1 would be our solution to this one. For this problem, we're solving this equation using square roots. That means I need to isolate this x squared term. A good step to doing that would be to get all the x squareds together. So if I subtract 1/5 x squared from 3/5 x squared, that's going to be 2/5 x squared. And then to get the x squared truly by itself, I have to get rid of this 2/5. I can do that by multiplying both sides by the reciprocal of 2/5, which is 5/2. So that gets rid of the 2/5 over here with the x squared. And then 2 times 5 over 2, the 2's actually cancel, so that's just 5. So we just end up with x squared equals 5. And now to actually solve for x, I have to square root both sides. Just remember that I get a plus or minus when I do that with an equation. So I have x equals plus or minus square root of 5. I can't simplify that radical anymore, so this one's done. To solve this equation using square roots, I'm going to first isolate the squared piece of it, this x plus 1 squared parentheses. To get that alone, one thing I can do is subtract 3 to the other side, so that's 18 over there. And then if I divide both sides by 2, that'll get the squared stuff completely alone, so that gives me 9 on the other side. At this point, to get rid of the square, I have to square root both sides, remembering that when I square root an equation, I have a plus or minus. So the square root of the left side, I've got just x plus 1, and on the right side, I'm going to write plus or minus 3, the square root of 9. Next up, to get x by itself, I have to subtract this 1 over to the right. So that's negative 1 plus or minus 3. And I should probably simplify my two different answers here. So I have negative 1 minus 3, which is negative 4. And then I also have negative 1 plus 3, which is positive 2. So those are my two answers. On this problem, I'm trying to solve this equation. Square rooting is probably a good way to go on this one. So one thing I can do to get the square root by itself is divide both sides by negative 1. So I've got positive x plus 9 squared equals negative 64. And then I can square root both sides to get rid of that square. So that's going to be x plus 9 equaling plus or minus square root of negative 64. And at this point, since I can't take the square root of a negative and get a real number, if I'm not looking for imaginary solutions, then I'm just going to say there is no real solution on this one. Now, later on in the curriculum, if we were allowed to use complex numbers, I could go a little further, but we're not there yet. For this problem, we have an application of solving by square rooting. So for a science competition, we have students designing a container that prevents an egg from breaking when it's dropped from a height of 50 feet. That sounds pretty impressive. The h function here below gives the height of the container after t seconds. So we want to know how long does the container take to hit the ground. In other words, when does h, at what t value does h have a value of 0? So to solve this, I just have to replace the h with 0. And now I just have to solve for t. One step to doing this, since I'm trying to isolate the squared function here, is subtract 50 from both sides. And then if I divide both sides by negative 16, that'll give me t squared. So let me just do that on Desmos. Negative 50 divided by negative 16 comes out to 3.125. And now I just have to square root both sides of this. So back on Desmos, let me just do sqrt, square root of 3.125, and that comes out to approximately 1.8. And that's going to be in seconds. Now you might be saying, hold on a sec, we square rooted an equation. Don't we also have a negative 1.8 seconds? Well, I mean, probably not in this situation. Normally, mathematically, yes. But in this real life setting, the concept of negative time doesn't really make sense. It doesn't make sense that the egg crate hit the ground a second, 1.8 seconds before it was dropped. So we're just going to discard the negative answer and keep our positive one.